With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is 7 rods A, B, C, D, E, F and G are joined as shown in the figure. All rods have equal cross-sectional area A and the length L. The thermal conductivities of the rod are Ka is equals to Kc is equals to K naught, Kb is equals to Kd is equals to 2 K naught, Ke is equals to 3 K naught, and Kf is equals to 4 K naught, and finally Kg is equals to 5 K naught. The rod E is kept at constant temperature T1 and the rod G is kept at a constant temperature of T2 where T2 is greater than T1. So that the rod F has a uniform temperature T is equals to T1 plus 2 times T2 divided by 3. And the second one is find the rate of the heat flowing from the source which maintains the temperature T2. Okay, so we have been given 7 rods A, B, C, D, E and F whose thermal conductivity is given to us as Ka and Kc have thermal conductivity of K naught. Okay, thermal conductivity of B and D are given as 2 times K naught. Correct. The thermal conductivity of the rod E is given as 3 times K naught. Of F is 4 times K naught and of the rod G is 5 times K naught. Correct. The temperature of the rod E is maintained at T1 and for the G is T2 and the temperature T2 is greater than T1. So we have to find the temperature of the rod F. Okay. And we have to show that the uniform temperature of the rod F is T is equals to T1 plus 2 times T2 by 3. So let us suppose that the rod F is maintained at a temperature T. Correct. So at a steady state both ends of the rod F will have the same temperature. Correct. So at steady state both ends of the rod F will have same temperature. Correct. That is T. Correct. Now at the steady state the heat flow from the rod from the both side will be equal. That is the heat flow from the rod A plus from the rod C will be equals to the heat flow from the rod B plus heat flow from the rod D. Correct. So Q from A plus Q from C will be equals to Q from B plus Q from D. Correct. Now writing down the equation for this we will get as Ka times area into the change in the temperature will be T1 minus T divided by the length plus Kc into area into T1 minus T upon length will be equal to Kb into area into T2 minus T divided by, sorry, we have written the wrong equation over here, so it not be T1 minus T, it will be T minus T. So writing it down again. Okay, so the equation for the heat flow from the rod A will be Ka into A T minus T1 divided by L plus Kc into A into T minus T1 upon L will be equals to Kb into A into T2 minus T divided by L plus Kd into A into T2 minus T divided by L. Correct. Now from here when we calculate it, what we get is Ka times T minus T1 plus Kc into T minus T1 will be equals to Kb T2 minus T plus Kd T2 minus T. Correct. Now the thermal conductivity of A, C, B and rod D is given in the question. Putting the values, what we get is K naught plus K naught into T minus T1 will be equals to 2 times K naught plus 2 times K naught into T2 minus T. Correct. From here what we get is T minus T1 will be equals to 2 times T2 minus T. Correct. Now on further solving it for the temperature T of rod B, we will get 2 times T2 plus T1 divided by 3. So this is what we have to prove. Correct, for the first part. Okay, so this is our answer for the first part. Let us suppose the first part. Now in the second part, what we have been asked is find the rate of heat flowing from the source which maintains at the temperature T2. Okay, so looking at the figure, what we can say is rod A and rod B are in series connection, rod C and rod D are in series connection. Correct. So write it down. Rod A and B are in series connection. Rod C and D are in series connection. Correct. Now, so the equivalent resistance for the rod AB will be equals to resistance of the A plus resistance of the B. Correct. Now, resistance is given as length upon Ka times area plus length upon Kb times area will be equals to L upon K naught A plus L upon 2 times K naught A. Correct. From here what we get is 1 plus 1 by 2 into L upon K naught A. Correct. From here the thermal resistance for the part AB will be given as 3 by 2 L upon K naught A. Correct. Similarly, for the rod CD, equivalent thermal resistance will be the resistance for the part C plus resistance for the part D. Correct. Now, the resistance for the part C and resistance for the part A is same, and for D and B are same. So, the equivalent resistance will come out as 3 by 2 L upon K naught A. Correct. Now, from the figure what we see is the equivalent resistance of this rod is RAB, and for this rod we have got as RCD. Correct. Now RAB and RCD are in parallels. Correct. So RAB and RCD are in parallel connection. Correct. So the equivalent resistance for this is R equivalent will be how much? R equivalent will come out as RAB into RCD divided by RAB plus RCD. Now substituting the values, RAB as 3 by 2 L upon K naught A into 3 by 2 into L upon K naught A divided by 3 by 2 L upon K naught A plus 3 by 2 L upon K naught A. From here what we get is our equivalent resistance, and it will coming as 3 by 4 L upon K naught A. Now so the heat flow rate will be given as Q by T will be the temperature difference, that is T2 minus T1 divided by the equivalent resistance. So T2 minus T1 divided by the equivalent resistance has come as 3L into 4 times K naught A. Correct. So our Q by T will be, so Q by T will be how much? 4 times K naught A into T2 minus T1 upon 3L. Okay, so this is our required answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.